there is a small lab we are having. Government of India has given this lab, use case lab for 5G. So I'll be demonstrating a small use case today on this 5G lab, and whatever is possible, I'll be able to show you. We'll be able to show you the packets and how we can capture different packets. But before going to those things, let us first of all see the basic differences between the 4G architecture and 5G architecture. So this is what we have done in our 4G. If you remember, uh, we were having a evolved packet core and IMS core, and there were entities like MME, HSS, service gateway, packet data network gateway, PCRF, and then in IMS we have got PCSCF, ICSCF, SCSCF, and HSS. HSS is at one place, but IMS is also able to access the HSS. Then we have our user equipment, and then these eNode Bs. So this is just for your memory recall that this architecture we have already done. We have done right from the registration of a mobile node to the SIP registration, and then finally how the call is getting transferred from one UE to another UE. That is the same use case we are going to take for 5G. And first of all, just see what are the differences between this 4G architecture and 5G architecture. This is the 5G architecture lab we are having here. And Miss, if you see the real implementation of 5G, uh, you'll find the similar things over there. Now, in our lab, we have this G node B. I'll show you after completing the theory part. I'll be showing you this G node B. Uh, we are having UEs, fine, and then other devices are also there. Uh, we don't have time to demonstrate the use cases for these other devices, but I'll be demonstrating a use case of UE. So we are having G node B. Then there is a rack, server switch rack. We do have a layer 2 switch, the firewall, and then this is the most important thing. There is one server which is having three virtual machines. In one virtual machine, we have this 5G core and IMS implemented together. And another virtual machine, we have network management system. And then there is third virtual machine, which I haven't written here. That is MEC VM, which interacts with the MEC server, which is the next server we are having. So in total, we are having two servers, two HA servers, one firewall, and one L2 switch. Now, if I just expand this particular server and the VM, it is having like this. So if I expand the 5G core part of our VM, uh, you'll find these modules. I'll be coming to the full form of these modules in a short while from now. So these are the different modules. Uh, and you'll ask me a question that how these modules are implemented. These modules are implemented as containers, and you people popularly know them as Dockers. And these these interfaces which I have shown here, these are service access points. Fine. So these are not actual interfaces. These are the if you have already seen somewhere the service-based architecture, that how inside a cloud services are implemented. These are implemented as containers, and then using a module known as SCP, Service Communication Protocol proxy, we say, these are all interconnected. Fine. So the AMF, the UPF, the SMF, and these different modules are implemented as Dockers, and these are all connected through service access point using a service connection proxies. Another part is similar to whatever we have in our 4G, the IMS thing, which have our own PCSCF, ICSCF, and SCSCF Dockers. There's one big change which has happened. If you see in 4G, these are the network boxes. Means these are the networking devices, uh, like switch, like a big firewall, where everything is bundled together. If you talk about MME or talk about SGW, these are big routers with all the logic implemented in the core. So these are the boxes, these are the hardware devices. In place of that, we have now network functions. And there is a technique known as network function virtualization. Means whatever network function was getting done by MME, it is getting virtualized in form of a container. So whole 5G core, the evolve packet core, which was hardware and all the communication lines, physical communication lines with different telecom protocols and different encapsulation like GTP and all, this is getting replaced by a simple cloud native architecture having containers, and these containers are connected together using a service connection protocol proxy. Fine. This is the biggest change. So you'll see and you'll be amazed after some time that whole 5G core is implemented in one server with all these Dockers. Obviously, this is a small, implementation of the 5G realization, where you will find that only one server is there. If it is a cloud native, you can create many instances of these containers to handle the load as and when the load is needed. Now, if you see this architecture, only one thing is there from our older 4G. That is the GTPU. What is GTP? The tunneling protocol, GPRS tunneling protocol. U means user plane. So finally, when everything is established, this particular interface, N3 interface, is getting used to transfer the actual data. Means after the session is established, the SIP messages, the actual RTP messages for voice call, everything transferred through this user plane through the UPF. What is UPF? We are just coming to that. Rest other things are technically same, only some names have been changed, and how those names have been changed and how the implementation has been done is going to be covered in the next slides. We are going very slowly and gradually. Wherever you feel any trouble, you can interrupt me. Fine. Now, what are the changes? As I already told you, that 4G LTE was node based, which is having evolved packet core with the different boxes, network boxes like MME, SGW, and PGWs. If we talk about 5G, we have shifted to a service oriented architecture, cloud native design, fine, with different network functions. So you can see that this is the term nowadays we use, that term is known as softwareization of network. So whatever network you were having is getting into a software form, into a form of a Docker where the logic has been implemented. When we come to the core signaling protocol, in 4G LTE, we were using GTPC, control plane, and diameter for having communication among the modules. If you remember, IMS used to uh, contact uh, PCRF used to contact the PGW on CX interface using diameter. SCSCF used to communicate with HSS using diameter. These were telecommunication protocol. MME used to talk to HSS using diameter protocol. There were protocols like S1AP, and GTPU was a user plane protocol we were using at that time. Now this has been replaced by plane interface, which is based on HTTP version 2 and having REST API. Now, if you don't know what is REST API, REST is nothing. You can bundle the REST request in form of any template. Generally, we use JSON. Um, this request can be bundled in JSON template, and then you can use simple methods like get, put, post, update. These methods, as we have already seen in our HTTP, these HTTP messages can be used to to gather the information, to share the information, to send the message, and this is where the REST API comes. When I say API, API is related to this service access point. These are the API hooks. Miss, you people use API. You get for the API, you send your request and then you get the answer. This is how you people use APIs in your design. Miss, the ultimate change was the telecom protocols have been replaced with web-based APIs. When we talk about mobility management in 4G LTE, the responsibility of mobility management was MME. That was a mobility management entity. It handles everything. Here it is getting handled by AMF, Access and Mobility Management Function. Now here everything is a function. Everything is a network function which is containerized. So this is our AMF, Mobility Management Function, and our AMF is connected to our G node B through N2 interface. Our G node B is connected to UPF through N3 interface. So if you see how our 5G core is connected to G node B, it is using two interfaces, N2 and N3. N2 interface is generally for control signaling, N3 interface is for your user plane data. Fine. So mobility management is getting done by AMF, access and mobility management function. When we talk about session management, remember every we have created so many TEIDs. Remember the tunnel endpoint identifiers between SGW and PGWs. SGW, if you see the 4G figure, here the TEIDs for control plane, data plane, here the TEIDs with control plane and data plane, and all these, and here the TEID between SGW and MME, and all these TEIDs have been stored per UE basis on MME. So your session management in 4G was distributed. MME was having all the control, means all the information base is there with MME. SGW was tunnel anchor, and PGW used to do the policy informant and IP allocation. Fine. So this session management, everything was controlled by in a distributed manner. Three entities are working together to manage the session. Here, session management is getting done by a single function, and that is known as SMF, session management function. This one. So majorly two things. Function management is by AMF and session management by SMF. These two functions handle mobility management and session management. Now, in reality, when I show you the connection between G node B and our 5G core, you'll find that a cable is going to, I'm drawing this cable, this is cable is going from G node B to our L2 switch. Via L2 switch, there is a firewall connectivity, and from firewall connectivity, it is going to 5G core. So it means there is only one cable which is running between 5G core and G node B. But I have shown you two interfaces. One is N2 interface, other is N3 interfaces. So physically, there is only one wire running between G node B and 5G core, but Logically, there are two interfaces, N2 and N3, one for user plane, other for control plane. And we have done one thing in our previous course, how we can create logical interfaces. Anybody can tell?
VLAN.
VLAN. Yes. Who told this? I can't see your name.
Sir Shashwat, C section.
Shashwat. Yeah. Yeah. You can have different VLAN. Nice answer, Shashwat. So on this interface, we can have different VLAN interfaces. One VLAN is going to take care of N3, other VLAN is going to take care of N2. Good answer. Fine. So this is how these things are done. Moving further, we have another function, that is user plane function, where your actual user data goes. If you see 4G LTE, we were handling this by two boxes. One is SGW and other was PGW, where the user plane data was going using that. If you remember, this was the path of 4G, that when you want to finally send data from G node B to another network or somewhere, you were using this GTPU, then again GTPU from PGW to another PGWs. This was the user plane for 4G. Here in 5G, user plane is concentrated into user plane function. So there are again, no distribution. There is UPF, user plane function. And now in this way, we can actually fully separate the control and data plane. Means when we talk about AMF and SMF, these are control plane. And when we talk about user plane function, this is data plane. Let me clear these things, and then it will be clear again. Let me just clear the white red markers. So if you see clearly, the user data will follow this path. N3 interface to UPF. From UPF, there is N6 line going towards different other operator IPX, and N6 lines again going towards the IMS. Remember, in 4G and 3G, we have used this term APN, access point network. That, okay, to which network your mobile want to connect to. Here, that APN is replaced by data network name, DNN. So for our mobile phone, generally there are two DNN. One is the IMS for setting the VoLTE call. It's not VoLTE now, it is voice over uh, voice over next generation, VONR we say. And another data network is our internet. Uh, so there are two data networks through which our mobile node is going to be connected. And the path is from G node B to the UPF, and from UPF to the data networks, whether it is internet or whether it is IMS. Fine. Moving further, uh, I told you user plane function. Then there was HSS, the subscriber data. Remember in 2G, 3G, it was, what was the name in 2G, 3G? Anybody can answer? In place of HSS?
HLR,
HLR, and one more was there,
VLR,
VLR.
visiting
Nice,
LR.
nice, nice. So HLR and VLR. Now in place of that, in 4G it was HSS, home subscriber server. But and here we have these two functions. One is unified data management, UDM, and other is unified data repository, UDR. Fine. So we have replaced HSS by these two functions, UDM and UDR. Here, one point I want to tell you, uh, and this is most important here. In this figure, you might ask me a question, sir, you are still using diameter and RX interface. Here again, you are using diameter and CX interface. Now I'll tell you, 5G core has been reinvented, but IMS is not reinvented. There are variety of reasons behind that. Uh, First of all, we need to have this 4G to 5G compatibility and connectivity. Another, they didn't want to redesign the IMS. IMS was basically for SIP, session initiation protocol, and SDP, session description protocol. And this is purely a telecom thing, telecommunication thing. So they didn't want to reinvent this IMS again. But the problem here is that whether you are going to use HSS or whether you are going to use the UDM and UDR. I told you that HSS is replaced by UDM and UDR. IMS does not know the web API. IMS is the old thing. IMS does not know how to use web API to enforce the policy. IMS does not know how to talk with PCRF. Here we call it PCF. IMS does not know web API style, does not know HTTP2. IMS knows DIA. IMS knows DIA. So what intelligently has been done, it is just like there is a translation happening. So the front end is shown to IMS like HSS. Front end is shown to IMS so that it can use DIA to enforce policy. And then in the back end, the translation function converted into the web API call. And DIA is converted into web API call. Means if IMS wants to talk to PCF, IMS by at its own end send the things using DIA, send the things using DIA, and HSS. IMS knows there is HSS. Internally, what you have done, and those who are working with the APIs, how many of you know about these wrappers? Anybody? Suppose I ask you a question. I have got a Python code. I want to use one utility which is in C++. Can we do this? Can we do this? In Python code, can you use C++ code? Yeah, this is possible using wrappers. You can write wrappers or translators where the interface shown to you is older interface, but you can convert into your own interface later on. That this is the important thing I want to tell you, because we still using HSS in IMS. So I told you about this user plane function, the UDM this. Then for authentication, MME used to have this connection with the HSS, interaction with HSS. For authentication here, there are two functions. AUSF is for authentication, which talks with UDM, and this AMF. So we have one network flow, function flow, which controls the authentication. Three network functions are used, the AMF, AUSF, and UDM for dedicated authentication function. In 4G LTE, see the figure of 4G, we were having PCRF. And IMS used to talk using diameter to PCRF to enforce the policy. To enforce the policy. We'll come into detail later. Policy means that what is going to be the bit rate, what is the delay, what is the quality of service, everything is enforced by PCRF. Here, in place of PCRF, we have PCF, policy control function, and it is again your web API driven policy control. Any question at this point of time? Any question from anybody? Shashwat, any question?
No, sir.
Okay. So we'll move further then. Moving ahead, the changes at E node B. We used to call it evolve node B in 4G. Here we call it next generation node B, G node B, or GNB in 5G. Again, there is a big change. This G node B, which was E node B before, it was monolithic. Everything in one. So means the antenna, the transceiver logic, the box within, everything is in one monolithic unit. What is G node B? It is converted or broken down into three units: control unit, distribution unit, and radio unit. Now for 5G, what is happening? Suppose there is a big city, generally we'll be having only one control unit somewhere in data center. Fine. Now these different G node B which are installed, or towers which are installed at different places in the city, they are going to have two things: the distributed unit everywhere, and then your tower or antenna, the radio unit. All these distributed units are connected by high speed link to our control unit. So your radio control is again getting centralized as a cloud native function. I don't have time to uh, teach you, and rather I don't know much about that also. Uh, Nowadays we have software defined radio, means the uh, we have discussed in our class the TDM plus FDM thing, that which frequency is there for which time. We still use OFDMA, orthogonal frequency division multiple access, plus TDM in 5G, but this is now getting controlled not by a hardware there or a transceiver there. It is getting controlled by a software running in control unit, and that is what is the software defined radio. This is again a new next generation radio. We call it next generation radio, we call it NGR, which is getting handled in this form. We don't have time to go into the details of that. Then remember, in 4G we used to have this GTPU sessions. So one was uh, default barrier bearer with the ECI 9. Other was dedicated barrier, we call it ECI 1. And then different endpoints for default barrier and dedicated barrier. We used to create this. For Voltecall, we used to have dedicated bearer. And for default, we used to have default bearer with less quality of service. Here, everything is being removed. It's a general IP Ethernet protocol data unit session, the way internet works. It's nothing like TIDs and everything else. Fine. It is just like generalized session, the way internet packet moves. Similarly, PDU sessions are there instead of different bearers. How to enforce the quality of service? We'll be coming to that, because you have to have different type of services needed, and to enforce different quality of service, we call them five QCI, that is known as 5G uh, quality of service index, 5 QCI, and how to enforce that into our PDO session, I'll be coming to that. Then our user plane code protocol, I told you GTPU over UDP IP, GTPU over UDP IP, there is no change from 4G. This is most important. The way we were having in 4G, remember 4G, GTPU, GTPU, And then outside here also it is GTPU, no change from 4G. Mobility handling, I told you, centralized at MME. Here it is handled by AMF, the mobility, and SMF, the session continuity. Means when we talk about handover, handover is controlled by session SMF, and mobility, location management, tracking area management is maintained by AMF. One, these are the advanced things which are still getting done. Fine. In 4G, there was no edge computing support. In 5G, we do have edge computing support. When I say this, it's like suppose you have a video analytics surveillance running by a camera. And when it is running by a camera, what will happen? It will go through your network, then go to a data center for analytics. Means network means 4G or 5G or network. Now in 5G, what you can do, you can implement your analytics in 5G core. I've shown you using this multi-access edge computing servers. And you can have many instances of this running. Means you are not required to have a separate data center to deal with cameras or IoT or something like that, or drone. You can have your logic, analytics logic implemented within the 5G core. That is the biggest, you can say, change from 4G to 5G. And depending upon uh, what kind of service is needed, uh, we can have network slices. I'll tell you one thing. What is network slice? We do have a server, having physical resources. Now you people can create VMs on this server using any hypervisor like VirtualBox or VMware. And these physical resources can be assigned to these virtual machines. That is how you create three virtual machine out of one physical machine. That is how cloud works. On similar lines, on one physical network, we can have different network slices. Fine. On similar line, we can have different network slices. And that is again supported by our 5G. It is still an area getting explored. IMS is unchanged. There is no issue in IMS. External data connectivity, in 4G it was via PGW, and in 5G it is via UPF, user plane function. Just quickly, the difference of language. When I talk about UE related lingo of 5G, same UE here, UE there. We call it Universal Subscriber Identity Module, which is just nothing but a SIM card storing subscriber data. Popularly, they are getting replaced by eSIMs. This is a new term, SUPI. This is known as Subscription Permanent Identifier. Um, the way we have IMSI in 4G, this is SUCI. You can conceal the identity by deploying some encryption algorithm. So this is known as subscription concealed identifier. IMSI still we are having. These are the legacy identifier of 4G and 3G. Then this is GUTI, globally unique temporary identifier. Remember in 4G, 2G, also we used to give TMSI, temporary IMSI, TIMSI for not disclosing the actual identity on the network. This is UE related 5G lingo. Now these are the core network function names. AMF, I told you, access and mobility management function handles registration and mobility. SMF is session management function, manages PDU protocol data unit sessions. UPF is user plane function, handles data traffic. AUSF is authentication server function. ये authentication के लिए है. UDM is unified data management, stores the subscriber data uh, like HSS. UDR is unified data repository. This is a database for UDM. PCF is policy control function. It was PCRF in 4G. QoS and policy control. Then network repository function. This actually is the interface which tells you which NF you require for your purpose. Actually, in reality, there would be many instances of UPF and different network function. As load increases, you can create one more UPF, one more UPF. And this is akin to our cloud computing. We can have horizontal scalability, creating different VMs or containers for different network functions. And then this NRF, network repository function, provides you the detail that which network function you can attach to. I told you about slice, network slice selection function. This is um, currently kind of unexplored. There are three fixed slice types. Enhanced mobile broadband for your call. Ultra reliable low latency communication for your these virtual reality, AR, VR, and camera related functions. And then MMTC, massive machine type communication for your IoT. So you can actually connect your different functions. In our lab, we have all the use cases. We have our AR, VR cameras. We have our 5G cameras to utilize this particular slice. For MMTC machine type, we have IoT gateway to utilize this slice. And for Voltec, all we have enhanced mobile broadband. UE to UE call flow. This is what we are going to do now. And first of all, let me explain the things. I'll again come to these slides when we'll be showing you the actual implementation. Fine. Because I'll take 5 minutes to set up my cameras to my devices so that you can easily see what is happening. First step is as before, uh, you store your USIM by SUPI. A key is stored to inside USIM means your SIM card, which is used for encryption, and then your default NSSAI means network slice selection assistant information, which slice you are going to use. Normally in your mobile phone, it is the pehla wala slice, that is enhanced mobile broadband slice, which is going to be loaded. This is detail of NSSAI that is known as slice type and the slide differentiator. So basically, it is like loading from your SIM to your phone. These things, SUPI, the encryption key, and default NSSAI on your SIM. Then obviously you will scan the radio environment and synchronizes with a suitable cell provided by JNB over UU interface using 5G NR physical layer procedure. So this is just like selecting the cell where you can get connection. Then your radio resource control protocol, you have a RRC connection by RRC connection request, RRC connection setup, and then RRC connection setup complete messages. This happens between UE and G node B. Uh, Today, I'll not be able to show you this RRC thing. This happens between your mobile phone and the G node B, the tower. Then, as in 4G, remember, we used to have this NAS. Using NAS, we attach our mobile phone, register our mobile phone to the 4G EPC, and then we get the IP address. All these things happen in this NAS thing. Remember, if you remember 4G, similar thing happens here uh, using next generation application protocol. Remember, in 4G it was S1 AP, and your NAS was getting done between G node B and MME, and the interface was S1 MME. Here in 5G, it is N2 interface, and we are using next generation application
Vinita,
protocol.
डीजी ऑन है यार, बंद कर देना लाइट वाइट.
Amit, mute
Sorry,
karo.
sorry, sorry.
Fine. Uh, then NGAP, next generation application protocol, we use for transferring the NAS attach request and other thing. Fine. Registration. The first step is, because you have the key with you, the key is with you, the SUPI with you, using the encryption algorithm, you create your SUCI, concealed identifier, and your default or requested NSSAI you'll send to AMF. See here in 5G, we have this interface from G node B to AMF. So you are sending everything, your SUCI and NSSAI to AMF. This is the first step. Fine. Now AMF will extract the non-access stratum, we call it NAS, and requested NSSAI. Now generally it is always same, the requested NSSAI and subscribe NSSAI from the UDM, generally it is same, and then depending upon the 5G core, what is the local allowed slice, you get the required slice for you. Optionally, it can query this network slice selection function for slice selection assistance. AMF sets the slice and set the SNSSAI values, which UE may use. And then finally, the station accept request is forwarded to UE with allowed NSSAI, GUTI, your global unique identifier, and plus registration area. I didn't want to go into this detail, but in 5G, there is the first thing is our cell. Many cells make tracking area, and then we have many tracking area together, and then they say registration area. Means you are not required to register again if you are moving in this area. Generally, it is a city long or a state long, depending upon the subscriber density. Key concept, SUCI, SNSSAI, NSSF, and allowed this. Fine. So it is privacy protected identity. I told you encryption of SUPI, single NSSAI, SST plus optional SD identifying one slice. This is the selection function, and finally authorized slice list written in registration accept. The interfaces which are used are UU, N2, NGAP and SCTP, NUDM and NSSF. These are not actually interfaces. If you see the figure of 5G, the NUDM is the, sorry, NUDM is our API, service access point, and NNSF is again our API service access point. Fine. Using this, we can communicate. This 5G core can communicate. Modules can communicate, and finally, the registration request is reply is sent back to the UE. The next step, same like 4G, we have to have authentication, obviously via network function AUSF using HTTP2. AUSF will talk with UDM. There it used to talk with the HSS to get the authentication vectors. The challenge is sent to UE via GNodeB over NGAP plus RRC radio resource control. UE checks and send the authentication response. AMF matches the response with the challenge. Success is there. Then AMF select the encryption algo, etc., and send to UE, and then UE returns security mode complete. It means from here to the AMF, our secure channel has been established. So after registration accept, after security registration, what is getting sent? Allowed NSSAI, 5G global identifier, registration area. U is now registered, authenticated, NAS secured, slice authorized, but still there is no IP connectivity. Next step is UE sends PDU session establishment request. This slide you have to spend some time with me. This is most important. And in this you will send whether you want IMS or whether you want internet, or if you are getting a mobile from any company, whether you want your company network, which DNN you want. So this PDU session establishment request DNN equal to IMS, and जो भी allowed NSSAI आपको मिली थी list, उसमें से one single NSSAI you will send in your establishment request. There may be many SMF instances running, session management function instances running. AMF selects the SMF instance for this NSSAI and DNN via NRF. I told you network repository function. Then there may be many UPF instances running. SMF selects suitable UPF which can actually provide desired quality of service to use this UE registration request or PDU session establishment request. Now this is most important. SMF establishes PFCP session with UPF over N4. I haven't shown N4 in my slides, but I'll tell you that is not N4 actually. I have shown it. SMF uses this interface, fine, because there may be many UPF. A UPF which is lightly loaded, which is relatively lightly loaded, will be selected, which can service this UE. And now you have to enforce some policies. Fine. And this is where you use this new protocol, a new protocol, which is known as PFCP. And it installs the PDR, FAR, and QER rules. This is like our SDN, where a controller installs the forwarding rules over network devices. So SMF is a controller and it is installing these PDR, FAR, and QER rules using this protocol. In an SDN, we use P4 runtime or uh, OpenFlow. These are the protocols to install the rules. Here again on the same lines, SMF is a controller which is installing the rules using PFCP. What is PFCP? Let me explain it. I've written this in the notes. I'm highlighting this. What SMF does, SMF establishes a PFCP, packet forwarding control protocol session with UPF over N4 interface using PFCP over UDP IP, installing forwarding rules such as PDR, packet detection rule, कि ये इस UPF के लिए है, इस पर्टिकुलर UE के लिए है, फॉरवर्डिंग एक्शन रूल, क्या करना है इस पैकेट का उस यूपीएफ को, और QER, QoS इन्फोर्समेंट रूल, किस लेवल का QoS इन्फोर्स करना है. And this in totality define packet detection, forwarding behavior and QoS enforcement. So जो काम आप लोग 4G में, if you remember, we used to have different bearer, that okay, this is dedicated bearer or डिफॉल्ट बियरर. सो अभी अगर आप थोड़ा सा दिमाग लगाएंगे तो ये हम थोड़ा सा डिफॉल्ट बियरर सेटअप करने का काम कर रहे हैं. So we are telling the UPF for this QoS rule, this forwarding rule, this packet detection. Now after this, UPF allocates the IP address for UE in IMS data network, and then SMF returns QoS flow info IP address to AMF, access and mobility management function. Now whatever SMF have done for UPF has been informed to AMF, same like you have established the default or dedicated bearer and you informed everything to the MME. Same thing is happening. AMF instructs, once AMF gets कि क्या क्या quality of service and everything है, so depending upon that it instructs GNB to create user plane resources. GNB establishes GTPU tunnel with UPF over N3 interface. Whatever QoS data is there, it is mapped on UU to assist RRC and software defined radio, because वहां भी वही QoS चाहिए radio link पे भी. So how to manage that QoS, that has been installed. AMF sends PDU session establishment except to UE with allocated IP and QoS parameters. Registration accept गया. Now UEA has active IMS PDU session bound to a specific slice, and same process will run independently for the UEB. Any questions at this point of time? Rest is same as whatever you have done in our 4G, thus SIP registration. So first step, as we know the proxy address PCSCF of IMS. The request SIP register is sent to PHCSCF over IMS PDU session. Abhi banaya piche. This PDU session has been made akin to our default barrier. IMS PDU session register is going to be there. Obviously, PCSCF will forward this to ICSCF using the same old interface MW and SIP. ICSCF will select the adequate SCSCF for this particular mobile or UE. Fine. It queries UDM oblique HSS, as I told you, using the wrapper function, and selects the appropriate SCSCF. As before, SCSCF issues unauthorized challenge to UE. UE responds with the credentials. Now SCSCF will verify over HSS regarding the UE. And finally, if verification is success, SCSCF will store the public identity, the contact address, and everything about this UE, and returns that registration is okay. So we'll show you this on our actual test bed in a just some point of time from now. Voice over IMS or voice over new generation radio, same thing. UEA will send invite having session description protocol parameter over IMS PDU session, which we have just made. PCSCF to SCSCF through ICSCF. PCSCF will add header, and everywhere we'll be able to say via, via every time the things are getting forwarded, we'll be going to see, and every node PCSCF, ICSCS will add some headers and forward the invite to the selected SCSCF. Suppose that SCSCF is another mobile, another operator, then we'll go via IPX using DNS. ICSCF will query UDM, as I told you, and it selects the UEB's SCSCF. In our case, our both UEA and UEB will be connected from same IMS, so will not be able to see the IX and different SCSCF here. UEB's SCSCF to PCSCF, UEB SIP invite is delivered. UEB returns trying, ringing, OK. And finally, UEA sends the acknowledgement that session is fully established. We'll be showing you all these on the Wireshark, that how the things are getting done. This is happening, and we have discussed in the class that parallelly one thing more happened. The dedicated bearer. PCSCF ask PCF, enforce the policy. PCF asks SMF, guaranteed bit rate QoS flow in IMS for the voltage, or sorry, 5G call, 5QI equal to 1 for guaranteed bit rate for voice, and SMF using, as I told you just now, using PFCP session enforces the QoS. So means here for voice, we are doing the same thing we did for 4G for the dedicated bearer. Obviously, after that, this information will go to AMF, and AMF will set up the GNB and GNB to UPF data plane for this quality of service. Finally, the everything is done. So your RTP media path, as I told you, UEA to GNB, GNB to UPF, UPF to IPX if different operator is involved, then UPF-B, then from UPF-B to G-Node-B, means G-Node-B of another mobile, and then to UEB on the UU interface. Fine. And I'll be showing you the RTP also working, where RTP is going to carry the SDP session description protocol parameters for which were requested while maintaining the SIP session. Lastly, there would be, after everything is done, a buy would be sent from UEB or UEA, whomsoever disconnects the call. So all those binding and PDU sessions will be released. All those bearers would be released, and everything is completed. If there is any question, you people can ask. We are done with the 5G description, and now the next part will start, where we'll be showing you how this works. Any questions? So just give me 2 minutes to set up the things. Fine. And I'll be then one by one, the way we have discussed in the slide, we'll be doing the things. People can see the camera here, Amit.
Yes, sir, I can see.
Okay, so this is the G Node B we were talking about. If you can see that this is, if you can see the camera, the G Node B is shown. Fine. Let me pin this. Fine. This is the G Node B, and then it is connected to this rack. This rack is there, and this rack is having the way I told you. The above one is our L2 switch, and then we have our firewall, and then we have two servers, HA servers. In one, we have our virtual machine for 5G core and IMS, the NMS, and the MEC interface virtual machine. And this server, the last one is our media access, sorry, multiple access edge computing server, where we can install our edge computing logics. Fine. Then these are some devices we have. If you can see, we have these two UEs which are configured for this G Node B. Uh, we get this 5G radio connectivity up to 30 meter using this G Node B. Uh, if we are in process to purchase the 5G spectrum, also the private 5G spectrum, using which we'll be going up to the 200 meters. Then we have this 5G drone, and then we are having this evaluation board also, where you actually do the calling and everything using the command line interpreter instead of using the mobile phone. Fine. Right now, these two mobile phones are in aeroplane mode. Fine. We'll be switching on these mobiles, and slowly and gradually you'll be able to see that how the call and registration and GAP, all these protocol works. Fine. We have one 5G camera also to check and run our video analytics solutions, the face recognition, everything on the uh, edge computing server and 5G core. This is what we are having. And now let's begin. So what I have done, if you see the slide, Amit, slides are visible?
It's on a video is visible, sir.
Slides are
Yes,
not
yes.
visible?
Slides are visible now.
Okay. So if you see the 5G lab architecture, you see this. Uh, this is our 5G core IP address, fine, and this is our IMS IP address. So 192.168.37.35 is our 5G core IP address. 192.168.37.38 is our IMS IP address. Our G node B IP address is this 192.168.37.15. Fine. Our UPF IP address is this 192.168.37.9. So I'll be referring, keep on coming to this figure again and again when I'll show you the Wireshark results and how the registration is done. Okay, fine. So let us see first of all the mobile phones show that they are on airplane mode. Both these mobile phones are on. If you see, these are. Is it visible properly? No. These have been set into flight mode. See here, both are set into the flight mode. Both are kind of disconnected. Is it visible, Amit?
Yes, sir, it's visible.
It's visible.
Highlighted. Airplane mode is highlighted, so you can
Airplane mode is
understand that
highlighted
is-
in both of these
Yes, sir.
mobile phones. Fine. Now, what I have done from the machine I am sitting, I have logged in to I've logged in to 37.35. 37.35 is our 5G core IP address, and I have logged into that machine. Fine. We'll be showing something here. Then what we are doing, we are running a Wireshark. We are going to run Wireshark, and because we are connected through a remote machine, so I am again using this 37.35 interface to capture the Wireshark packets. Okay, so let me start it and let me stop it also. Fine. So when I'll do the things, I'll show you. Fine. Uh, बात क्या था? आप ये दिख रहा है कमांड?
Yes, sir. Command CD आप कितना लिखा है?
अच्छा, ठीक है. तो चलो क्या कर रहे हैं, हम इसके लॉग फाइल देखना चाह रहे हैं. ठीक है. So if you see here, there are these logs, AMF log, AUSF log, and HSS log, MME log, all these log files are there. So what we are interested in, we are interested right now in SMF log, and that's what we are going to see. Fine. Right. So now what we are going to do, we are going to do one by one. Remove कर दो पहले दोनों को flight mode पे लाओ. हाँ. What we are going to do, we are doing. कैमरा नहीं दिख रहा होगा, आप कैमरा दिख रहा है? अमित?
हाँ सर, कैमरा में दिख रहा है.
अच्छा, अब एक flight mode. What we are going to do, we are going to move it from one mobile from flight mode to uh, uh, नॉर्मल मोड मीन्स लिखेंगे क्या हुआ है, और साथ ही साथ हमको देखना है कि कुछ एनजीएपी चला कि नहीं चला। तो हम फिल्टर डाल रहे हैं इसमें, एनजीएपी करो, कैप्चर करेंगे। एक ऑन किया मैंने मोबाइल, लेकिन लॉग में क्या हो रहा है, इफ यू सी इन लॉग, see here we got DNN internet IP address 10.45.0.93 IP एड्रेस मिल गया हमारे मोबाइल को। और एक खास बात है, I told you this in class also, that we have got IP address for IMS also. So this IP address is for IMS, means when you talk with IMS for SIP and everything, this we got. And another IP address, when finally our RTP, voice over next generation radio will go, that is the IP address. So one DNN equal to internet and IP address this, another DNN equal to IMS and IP address this. We'll be able to see this IP address. Fine. We'll be able to see this IP address, that DNN equal to uh, इंटरनेट। सी दिस, क्या है वहां पे लॉग में, और यहाँ पे सेम है अमित।
सर ब्लर है बस बहुत सारा।
अभी अभी एक मिनट कैमरा देखें।
और 37 है लास्ट में सर।
यही चक्कर हो रहा है, एक मिनट को। ऐसे दिखाएंगे, दूर से दिखाओ थोड़ा सा। नहीं दिख रहा है,
विजिबल नहीं है सर, बहुत लाइट का रिफ्लेक्शन बहुत ज्यादा आ रहा है फोन में।
लाइट का रिफ्लेक्शन आ रहा है बहुत। लाइट बंद करने से
सर
चलेगा क्या?
ओके
आई जस्ट वांटेड टू शो यू कि यही आईपी एड्रेस मिला है।
सर फोन का, किसी का फोन से कनेक्ट करेंगे तो हो सकता है क्लियर आ जाए। आप वेबकैम पे हैं क्या?
हाँ वेब कैम पे है। एनीवे एनीवे
सर सही वही होगा आप कह रहे हैं तो।
anyway, that's the same IP address. नहीं दिखेगा सर, पास से भी नहीं दिख रहा। एक्चुअली उसमें भी लाइट है ना। या तो ऐसा करते हैं, इसका स्क्रीनशॉट लेके व्हाट्सएप करो। हाँ ठीक है, आपने को खुद को व्हाट्सएप करो, तुम्हारा व्हाट्सएप कहीं खुला होगा। Anyway, we will show you this thing later on. This same IP address has been given to the mobile phone, and this is in their log. Let's see NGAP कुछ पकड़ पाए क्या? NGAP हम लोग पकड़ पाए क्या कुछ? नेक्स्ट, दूसरे मोबाइल को स्विच ऑन करो। We have switched on the another mobile, and another mobile also got IP address. So one has got 93, and we are seeing here that mobile has got the IP address 10.45.94, 0.94. So these two IP addresses were there. Now see here, this NGAP, I told you, NGAP NAS is happening. dot 10. Fine. And I told you G node B IP address 37.15. It is going to AMF 37.10. So NGAP protocol is running, and using that NGAP, things are getting done. NGAP PDU, and we have all these things which are NGAP runs within SCTP, as we have already discussed, which is encapsulated by Internet Protocol. Internet Protocol, you can see that source is this G node B IP address, and destination is our AMF IP address. Fine, 37.10. And in this path only, our NGAP runs from G node B to AMF, and that is what is getting captured in the Wireshark. Fine. Now, what we are going to do is, next step, what we are going to do is we are going to call from one mobile to another mobile. But before that, let me clear this, capture this, and we'll be calling and we'll be capturing the SIP. So if you see, we are making a call from one mobile to another mobile. Call करके काट देना तुरंत, and you can see call is there, and then we are cutting the call. We are cutting the call. Fine. Call has been cut. Now, if you can see clearly that you see invite, 100 trying, 100 trying, okay, acknowledgement, ringing, 180 ringing, all these messages are getting sent from one place to another place. Now, do one thing. Uh, enabling it, IP address will change. क्या किए? हाँ, डिसेबल करो, ठीक है? अब इनेबल करो। इनेबल करो। कर दिया इनेबल? There's another way of seeing the thing. Seven. What I'm doing, there is a utility known as SNGrep. Using this, you can check what is happening on the core regarding SIP functions or SIP messages. See here, we are able to see the register messages. The way I told you, registration messages So it started with node. So this is the IP address of the node, and then it was getting forwarded to the different nodes. So this is, you can see, I told you, IP address of IMS, and port number 5060 is port number of PCSCF. This is IP address of IMS, but port number of 4060 is ICSCF. This is IP address of IMF, and port number 6060 is port of SCSCF. So your registration request is getting forwarded to these. Finally, it is going towards our destination registration. Fine, and it is okay trying, and finally you get the node is registered. Fine. I think it will be shown in our this also. Let me see. You can see here this register message. रजिस्टर, अभी रजिस्टर का देखिए क्या है. If you see, register is going from the mobile node to IMS. Source is mobile node, destination is IMS. रजिस्टर गया, उसने बोला, जवाब दिया IMS ने नोड को, सोर्स इज IMS एंड डेस्टिनेशन इज मोबाइल नोड. हाँ भाई, ट्राई कर रहा है. अगला स्टेप क्या है? IMS को बढ़ाया. नहीं भैया, IMS ने IMS को नहीं बढ़ाया. अब मैं आपको इस पैकेट को दिखाता हूं. आगे चलेंगे, इस पैकेट में नीचे देखिए, IMS ने IMS को नहीं बढ़ाया. IMS ने बढ़ाया, ये देखिए, सोर्स पोर्ट क्या है TCP का 5060, डेस्टिनेशन पोर्ट 4060. IMS ने किसको बढ़ा दिया रिक्वेस्ट? ये रजिस्ट्रेशन रिक्वेस्ट आगे बढ़ाई IMS टू PCSCF टू ICSCF. पहले IMS पे गई रजिस्टर्ड रिक्वेस्ट, दिस इज IMS. PCSCF पे गई. अब यहाँ पे पोर्ट दिखाएं आपको, इसका देखिएगा, डेस्टिनेशन का TCP पोर्ट if you see here the GPRS, this is fine. Now if you see, the initial request goes from register request goes from your node to the destination. This is IMS. Fine, it goes to IMS. वो कहेगा यार हम ट्राई कर रहे हैं, लेकिन हम IMS तक पहुंच कैसे सकते हैं? IMS तक पहुंचना है हमको, ये तो यही पाथ लेना है. फाइन, मीन्स पहले N3 से N6, then IMS. Means we have to follow GTPU, and that's what is getting shown here, that you have this बाहर का IP address, IMS से UPF. ये बाहर का IP एड्रेस क्या है? 3715 G नोड B और 3709 UPF. देखिए, आउटर हेडर IP एड्रेस 3715 G नोड B और UPF का IP एड्रेस 3709. ठीक है, ये बाहर का हेडर हो गया. अब नीचे चलते हैं, बाहर का हेडर लग गया, इंटरनेट प्रोटोकॉल हो गया. अब नीचे आएंगे, फिर हमारा क्या है? UDP, जो आपको क्लास से पोर्ट नंबर बताए थे GTPU के, डेस्टिनेशन पोर्ट, सोर्स पोर्ट, GTPU. फिर देन वी हैव आवर GPRS टनलिंग प्रोटोकॉल. अब इसके बाद एक्चुअल हेडर शुरू हुआ. सोर्स क्या था? मोबाइल नोड का IP एड्रेस, और डेस्टिनेशन क्या है? IMS। फाइन, ये इंटरनल हेडर, इंटरनल हेडर के बाद सोर्स पोर्ट कोई भी नोड ने अपना यूज किया 42199। डेस्टिनेशन पोर्ट क्या है? 5060 मींस PCSCF का डेस्टिनेशन पोर्ट है। So this request, first request is going from your node to the PCSCF, destination port is 5060। पहला स्टेप हो गया रजिस्टर का। जवाब क्या आया भाई? ट्राई कर रहे हैं, जवाब मिल गया यूई को, फ्रॉम IMS टू यूई। नेक्स्ट स्टेप, अब IMS के अंदर ही खेल होगा, PCSCF से ICSCF। अंदर क्या खेल हुआ? अब अंदर GTP नहीं है, अंदर हमारी आराम से जो IP वो प्रोटोकॉल है वही चल रही है। इसमें देखिए, इसका जरा देखते हैं क्या है भाई। तो इंटरनेट प्रोटोकॉल, IP एड्रेस दोनों के सेम, सोर्स भी 3738 और डेस्टिनेशन भी 3738। आगे बढ़े, TCP देखें भाई, TCP में क्या है? हाँ, पोर्ट नंबर 5060 सोर्स पोर्ट, डेस्टिनेशन पोर्ट इज 4060। ये किसका है? ICSCF। चलो भाई, यहां तक पहुंच गया। 100 ट्राइंग, फिर मिलने लगा 100 ट्राइंग, उसने आगे बढ़ा दी। आगे देख कहां बढ़ी, आगे भी वही है, IMS के अंदर ही खेल रहे हैं। तो अब उसने फिर देखेंगे 4060 जो ICSCF का था, आगे कहां बढ़ा दिया उसने? 6060। आपकी रजिस्ट्रेशन रिक्वेस्ट चली गई, सब दिखाऊंगा, चिंता मत करना, ठीक है। रजिस्ट्रेशन चली गई, कहां चली गई? SCSCF पे। SCSCF ने कहा कि नहीं भाई, चैलेंज करो भाई को। अब ये जो चैलेंज है ये फिर उल्टा जाएगा, 3 बार चैलेंज जाएगा। SCSCF से ICSCF, ICSCF से PCSCF और PCSCF से यूई। तो 2 बार देखिए आपस में गया और फिर बाद में यूई के पास गया। फिर यूई से जो रिक्वेस्ट आती है वो दिखती नहीं है, क्योंकि आपका IP सेक बन गया है। यूई से जो रिक्वेस्ट आती है, हमने SIP सेलेक्ट किया हुआ है, तो यूई से जो रिक्वेस्ट आती है वो दिखती नहीं है। लेकिन फाइनली एट PCSCF यू हैव दिस registration done and your OK is there. Any questions? And this is shown here also. Fine. This is shown here in SNGREP also. Any questions?
सर आपने कहा चैलेंज का रिप्लाई नहीं दिख रहा है।
हाँ, अब वो क्यों नहीं दिखा तुम बताओ।
सर
सिक्योरिटी मोड वाला स्टेप ध्यान है। देखो हमको क्या दिख रहा है, हम जो भी देख पा रहे हैं वो कहां से देख पा रहे हैं? हम यहां से देख पा रहे हैं। बात समझ में आया? हमारे वायशाख में क्या दिख रहा है? SIP जब यहाँ पे आ गया तो हम यहाँ पे देख पा रहे हैं SIP गया, फिर यहाँ गया, यहाँ गया, यहाँ गया। यहां से यहां तक जो SIP गया, ठीक है, जो भी SIP का मैसेज गया वो हम नहीं देख पा रहे। क्यों नहीं देख पा रहे? कुछ बताइए। नहीं ध्यान आ रहा है? ये देखिए, पहला स्टेप क्या था? सिक्योरिटी मोड कमांड, रिमेंबर? Once this is done, between G node B and your 5G core, everything is encrypted. अभी हम दिखा दें इसको, यूई वाला? यूई वाला दिखा दो यार इन लोग को। ऐसा करो, ESP चल पाएगा? नहीं, शायद कुछ दे दे। ज्यादा हो गया क्या? नहीं, दे दिया यार। सी हियर, जो कुछ भी यूई से आ रहा है, ठीक है, वो सब एन्क्रिप्टेड है। ESP क्या है? ये IPsec वाला प्रोटोकॉल है। GTP टनल, इंटरनेट हेडर, उसके बाद सब कुछ इनकैप्सुलेटिंग सिक्योरिटी पेलोड के अंदर उसने छुपा दिया। इसलिए तुमको यूई से यहाँ तक कुछ नहीं दिख रहा है। हम जो कुछ भी देख पा रहे हैं वो यहाँ के बाद देख पा रहे हैं, क्योंकि यहाँ पे डिक्रिप्शन हो गया जब हम IMS पे पहुंच गए, और उसके बाद वो सब दिखना शुरू हो गया। समझ में आया?
हाँ सर।
ठीक है, हाँ, गुड गुड। और कोई क्वेश्चन?
कह रहे मन कर रहा है बस, आएगा नहीं।
चलो, अब हम कॉल करेंगे तो इनवाइट दिखेगा। ठीक है, अभी हम एक बार बंद कर देते हैं वायशार्क। ठीक है, और इसको SIP कर देते हैं फिल्टर को, और वायशार्क चलाएंगे और हम कॉल भी करेंगे। कॉल करो। कौन बोला? अच्छा, वो वाला। अच्छा, हाँ। अरे रुको यार, सॉरी सॉरी सॉरी। हाँ, ये वाला ना। हाँ, कॉल करो। अभी बोलना नहीं, अभी केवल कॉल करो, बोलना RTP बाद में दिखाई। बंद कर दो। हमने कॉल किया और कॉल बंद कर दिया। ठीक है, मतलब उठाया नहीं फोन, फोन उठाया नहीं, खाली घंटी बजी है। एंड दैट्स व्हाट आई वांटेड टू शो यू। इनवाइट, SIP, फिर वही चक्कर है, हम यूई से यहां तक नहीं देख पाएंगे, यूई के अंदर ही देख पाएंगे। इसका अगर हम ध्यान से देखिएगा आप, सो SIP और साथ में SDP भी है, सेशन डिस्क्रिप्शन प्रोटोकॉल। लेट अस सी दिस। क्या क्या है इसमें? सोर्स ये, डेस्टिनेशन ये, और पोर्ट नंबर 60 से 50-60 में इनवाइट जा रहा है, मींस PCSCF से ICSCF पे। और सिप प्रोटोकॉल इनवाइट है, रिक्वेस्ट लाइन है इनवाइट की। ठीक है, मैसेज हेडर, ये मैसेज हेडर है, सब कुछ है। कॉल आया कहां से अभी पता चल जाएगा। ये आया भाई, देखो ये IP एड्रेस दिखा हमको कि यहां से कॉल आया। ठीक है, ये इनवाइट बढ़ता गया, और आखिरी में देखिए ये मैसेज बॉडी, दिस मैसेज बॉडी एक्चुअली दिस इज SDP, सेशन डिस्क्रिप्शन प्रोटोकॉल। और ये इन सेशन डिस्क्रिप्शन प्रोटोकॉल we are able to see lot of thing, that what do you want in this session. Fine. So important thing is we will be using RTP protocol, we'll be using AMR, wideband. What is AMR? Multi-rate, adaptive multi-rate with wideband. This is going to be the codec information, everything is in the session description protocol. Fine. So this we are able to see, and if we see further, this SIP will go finally 100 trying, then 180 ringing, and then finally OK means this invite is over. अब एक बार हम लोग फिर से कॉल करने जा रहे हैं, और इस बार हम फोन उठाएंगे भी। ठीक है, फोन उठा के बात करेंगे, और फिर हम आपको दिखाना चाहते हैं लास्ट चीज, दैट इज रियल टाइम प्रोटोकॉल। रुक जाना। कॉल करूं? हमने फोन उठा भी लिया है और हम बात भी कर रहे हैं। हेलो, हाँ आवाज आ रही है ना? हाँ ठीक 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 ठीक, गुड 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 गुड, ठीक, काट दो। ठीक, हमने कॉल किया, डेटा भेजा वॉइस, एंड नाउ सी आरटीपी पकड़ पा रहे क्या? ये देखिए, जो हमने आपको सेशन डिस्क्रिप्शन में दिखाया था वो सब दिख रहा है। एक पैकेट उठाएं क्या? देखो जीटीपी लगेगा ही लगेगा क्योंकि यूजर प्लेन से जा रहा है। अरे बड़ा बढ़िया दिखा रहा है यार, दोनों सोर्स डेस्टिनेशन भी दिखा रहा है। हाँ, क्यों बच्चा लोग? एक हमारा सोर्स है जहां से एक डेटा गया और एक डेस्टिनेशन है, आईपी एड्रेस है मोबाइल फोन के। अब इसका जरा देखा जाए पूरा डिटेल, तो सोर्स बाहर वाला तो जी नोड भी है और बाहर वाले हेडर का, और 37.9 AMF है, 37.15 जी नोड भी ये गया, बाहर का हेडर लग गया, यूडीपी लग गया, जीटीपी यू का 2152 टनलिंग प्रोटोकॉल आ गई, एंड देन फाइनली वी हैव these two mobile phones, their IP address from .91 to .92. Keep on seeing this, keep on seeing this. फिर यूडीपी लग गई हमारी, फाइनली रियल टाइम ट्रांसपोर्ट प्रोटोकॉल। सी हियर, दिस इज रियल टाइम। रियल टाइम से हमारा डेटा गया और रियल टाइम ने अंदर यूज क्या किया है? एडेप्टिव मल्टी रेट विच वाज रिक्वेस्टेड ड्यूरिंग इनवाइट when session was getting established, and accordingly the multi-rate quality of service will be enforced using PCF over UPF. See here, this is what is the requested thing, and this is real-time transport protocol which is getting inside GTP U header. Got the point? So this is the whole UE to UE call use case. I hope I have given you something. It was very difficult to explain everything in a remote manner, but I have tried my level best to give you some details so that you can at least get some flavors of the thing. And if there is any question, I'm happy to take. Physically, it is not possible because there are so many students. If there is any question, I'm happy to answer. Yeah, Shashwat, any question?
Sir, I am myself not sure about this point, so I just wanted to ask, sir, you talk about quality of service QCI in class. So
Uh-huh.
how is that?
How is
was
that
that, sir,
implemented?
shown? Yeah, shown
Okay.
here as well. So I wasn't able to
Shown
follow that.
here, that is internal function actually. The quality of service, how it is implemented, because we were able to support AMR, it means this is QCI one. How this is implemented, because look, who implemented this quality of service? Finally, this is the setup, no? See the slide? Slide is visible?
Yes, sir. visible.
Yes, sir,
Yeah.
slide is visible.
So this is PCSCF to PCF. Here your guaranteed bit rate is ensured QCI equal to 1. There it was QCI, there it is 5 QI. And now this SMF to UPF, this here the quality is getting enforced using our that protocol PFCP protocol. So PFCP session modification, UPF enforces the QS, and then it is informed back to our G node B also. Now, how this is enforced, for this you have to come with me and we have to see the UPF logs, because in those logs everything is mentioned. Whatever action is happening, they are logged in UPF and SMF log. When you'll come that, I'll be able to show you this PFCP thing also. Another thing, bacha log, I'll tell you, which I don't know we haven't done this on network lab. There are certain protocols which are by default added in our Wireshark. Like RTP was not added. So what we have to do, we have to go there in the preferences, and then we have to add the protocols. That okay, you want to see, and similarly, I don't know, I haven't checked that whether we'll be able to see that PFCP also. That okay, PFCP is whether it is not there, if we are able to add it up, we'll be able to see that PFCP protocol session also, that how UPF maintains this session with the SMF. So let me figure it out. But right now, I think we can see it in log. Let me check if it is there in the log. I'll send you in the slides. I'll include a slide of this SMF log where this quality of service things are enforced. Any other question? Question note कर लो ये. Amit, any question?
नहीं सर.
Any if there is no other question, then we can stop. Thanks a lot. The lab is here only. I am here only. If you want to work, there is a lot of possibility. This is a kind of, for me, the source is also open. We can do a lot of work here. Here. If you are interested, you can always come, and you are welcome. Thank you. ठीक है अमित, बंद कर देना.
Thank you, sir.
Okay. Recording save कर लेना अमित.
ठीक सर. ओके.
Okay.
सेव्ड.
मैं लीव कर रहा हूँ.
ओके सर.